Number 17 here is getting us into these distance problems. So let's read what's going on here, guys. They also gave you a hint right here that I think is going to make this problem a lot easier for you. So we're supposed to find the point on the line y equals x. So let me start just by graphing all this thing right here. And we want to minimize the distance from that line to the point 1, 0. So I'm going to draw this on a relatively big scale here, guys. Y equals x, of course, is going to look something like... Here we go, passing through the origin, slope of 1. Okay, so there is the line y equals x, and we want to minimize the distance from that line to this point right here, which is the ordered pair 1, 0. Now, I hate to say this, you can actually solve this problem using geometry, because you guys learned that the shortest possible distance between a line and a point not on the line is not to draw a segment at an angle like this, or even more of an angle like this. What you want to do is draw the segment here that goes perpendicular to that original line, and that distance right there is the shortest possible distance from a point to a line. But you know what? Not everybody remembers geometry as well as I do, so let's just treat this like a floating dot problem, and that means that there's some random point, and I'm not going to make this obvious right here, some random point right here that we are going to generically call x comma y. And that point minimizes, that's the shortest possible distance between the point 1, 0 and then the point x comma y. So let's get working on figuring out what that distance is right there, guys, in order to do that. Well, the first thing I would have you do for your parameter right here is try to come up with the relationship between x and y. Well, that's given by the equation of this line right here. No matter where on that blue line that I put that red point, x comma y, the y coordinate is equal to the x coordinate. So x equals y really is your parameter, everybody. That's going to come in handy. Now let's move on to step 2. Write an equation for what it is we're trying to minimize. We want to minimize d, the distance right here. And the distance formula then, guys, if you recall, between 2 points on the coordinate plane is this. This is just a variation of the Pythagorean theorem. The distance formula is going to be x1 minus x2 quantity squared plus y1 minus y2 quantity squared as well. So that's the formula we would now have to differentiate in order to minimize. But I'm going to use this hint right now. It's equivalent and easier to minimize the square of the distance. So I'm going to square both sides of this equation now and get d squared equals, and on the right side, squaring it will just get rid of the square root. x1 minus x2, close it, square it, plus y1 minus y2, close it, and square it. Okay, so that's what we're trying to mess with right now here, guys. All right, so with that in mind, let's see where we can go from here. I don't think we're ready to differentiate that just yet. We now know a couple of the things that we're dealing with. We're going to be using this point right over here, xy, and this point right over here, 1, 0, to put in for all of these values right over here. So let's keep going here in step 2. d2 is going to equal, and here we go. We're subtracting our x coordinates, so I'm going to write that as x minus 1. X minus 1 quantity squared plus, and now I'll do the same thing with the y coordinates, y minus 0. But of course, remember, y is just equal to x. So I could write this thing y minus 0, which of course would just be y squared, but I'm better off remembering that y and x are really the same thing if they're on the line y equals x. So I'm just going to make that an x minus 0, or x squared. And I think, actually, that wouldn't be that bad to differentiate the way that it is right now. Yeah, you know what? I was actually going to expand the x minus 1 squared, but I don't think this is terrible. So if I don't regret this, oh, no, wait. I'd have to implicitly do the left side as well. Huh, that's kind of interesting right here. Okay, we want to take that derivative, we want to set that equal to 0. I'm going to go ahead then and let's jump into step 3 right here, and let's take the derivative of both sides with respect to x. So, interesting. So we're doing a d dx here on the left and a d dx, here on the right. So that left side is interesting. It's now implicit. This would be a 2d multiplied by a dx right there. Huh, fun. And on the right side, all right, differentiating x minus 1 quantity squared, 2 times x minus 1 to the first power, didn't need to write that, so 2 times x minus 1 times the derivative within, which would be just plain old x. Okay, and then from there, this would be a plus, and the derivative of x squared is just going to be a 2x. And I'm trying to see here, guys, if we would set that thing equal to 0, I suppose at this point then we could say we would divide both sides by 2d, and that's why that becomes irrelevant here. So I think if I did that, I'd just be dividing by a 2d, and obviously d is not going to be 0. So I think I can just say dx is equal to, all right, and if I set this equal to 0, that would be I'm distributing here, 2x minus 2 plus 2x. So that would be a 4x minus 2. We would set that equal to 0 and now solve for x. And why are you not moving? All right, here. Oh, possibly because I didn't do that. Okay, guys. So with that in mind, not too hard to solve here. 4x is equal to 2 and x would equal 1/2. So let's go back right here and see what they wanted us to do as I move on into step 4. Find the point on the line y equals x. So we're looking for this point right here. We just found the x coordinate. So the x coordinate is going to be 1/2, and the y coordinate, let's remember guys, is equal to the x coordinate. So that's going to be the ordered pair 1/2, 1/2, which if you had kind of run with what I said before about geometrically figuring this out right here, I think you would have found like, oh yeah, that's kind of the center point of this square right over here at the point 1/2, 1/2. So hopefully that makes a little sense geometrically after we got the answer using calculus as well for number 17.